Good morning, happy Monday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu. and I'll respond as soon as I can. All right, today we're going to go on and take a look at section 5.7. But before we do that, we have some questions requested from section 5.6. So let's take a look. All right. 5.6. This is number 7. It says multiply. Simplify your answer completely. We have negative 4b cubed times the quantity 3b squared minus 3b plus 3. So we're going to be distributing the negative 4b cubed. So negative 4b cubed times 3b squared would be negative 12b to the 5th, that is b cubed times b squared. We add the exponents, b to the 5th. Negative 4b cubed times minus 3b, negative times negative or negative times minus is plus, 4 times 3 is 12, b to the 3rd times b to the 1, there's an implied 1 exponent, is b to the 4th. And then finally, negative 4b cubed times 3 is negative 12b cubed. Now, we can't do anything more with these because these are terms and they are not like terms. So we don't add the exponents or anything. Any questions about that one? Okay, let's take a look at, again, section 5.6, number 22. All right. Perform the indicated operation to simplify the expression if possible. If the expression cannot be simplified, enter the given expression. Okay, and we have a plus 9 times a squared minus 9a plus 81. So we're going to multiply the binomial times the trinomial. So first of all, a times a squared would be a cubed. A times minus 9a would be minus 9a squared. A times a positive 81 would be plus 81a. Moving on, 9 times a squared would be plus 9a squared. 9 times minus 9a would be, oh, you know what? I made a mistake. Let's go back here. Right here. Oh, wait a minute. Maybe not. Hang on. Don't panic. Let's see. We'll find out. Let's see here. I thought I made a mistake. Maybe not. Let's see. 9 times minus 9a, is minus 81a. Okay, sorry. I thought I made a mistake, but turns out I didn't. Lucky day. And then 9 times 81 would be plus, let's see, what is that? 729. All right, guess I'm just still waking up. Combining like terms, these are like terms, they would cancel. These are like terms, they would cancel. I've got a cubed plus 729. And there's my final answer. Any questions about that one? Okay. This is 5.6, number 23, part A. And we have 1/2 C minus 6D plus the quantity 1/4 C plus D. Okay, here we are adding or subtracting. We are not multiplying. So in front of the first set of parentheses, there's nothing. So I can just bring down the contents without the parentheses, and then having a plus sign in front, distributing that, you get plus 1/4 C plus D. Okay, so now we're going to combine like terms. Those two are like terms, and those two are like terms. The 1/2 C plus 1/4 C, to add those, I need a common denominator, which is 4. So 1/2 C plus 1/4 C. How many fourths C plus how many fourths C? Well, 1/2 I'm going to multiply by 2/2 to get 2/4. 1/4, it ain't broke, so don't fix it. 2/4 plus 1/4 would be 3/4, and then C. Any questions there? All right, then minus 6D plus D would be minus 5D. So there is 23 part A. Now we're going to go on to 23 part B, which is the same two polynomials, except now we're going to multiply them instead of add them. 1/2 C minus 6D times 1/4 C plus D. So 1/2 C times 1/2 C. If you've got 1/2 C times 1/4 C, multiplying a half times a fourth, you multiply the fraction straight across, so that would be 1/8 C squared. Then plus 1/2 CD, okay, minus 6D times 1/4 C. 6/4 could be reduced to 3/2, so I've got minus 3/2 C D, okay, and then finally minus 6D times D would be minus 6D squared. Combining like terms, 1/8 C squared plus 1/2 CD minus 3/2 CD would be plus 2/2 CD, which would be plus, wouldn't be plus 2/2, it'd be plus or minus 2/2, right? Because we've got a half minus 3/2. So that's minus 2/2 CD, which is minus 1 CD, which is minus CD, and then minus 6D squared. So again, 1/2 minus 3/2 equals negative 2/2 equals negative 1, but we don't have to put the 1 in front of the CD. In fact, just a reminder, if you put the 1 there, WebAssign is most likely going to not recognize it and mark it wrong. So there's the final answer to 23 part B. Any other questions from anybody before we continue? All right, we're going to go on, as I mentioned earlier, to section 5.7, which is called special products. Okay, we're pretty much going to do the same thing we did before in the previous section, and that is multiply polynomials together, except sometimes they may look a little different up front, and the results to some of them may be surprising. All right, let's say we've got the following: y plus 7 times y plus 7. So foiling this together, we would get y squared plus 7y plus 7y plus 49. Combining like terms, y squared plus 14y plus 49. Okay, now, what if we had y plus 7, the quantity, squared? That's the same thing as this if we were to expand it. It would be y plus 2 times y plus 2. Any questions how I got from here to here? This says I have a base of y plus 7 and I have 2 factors of that base. So now I'm going to FOIL it together. Y squared. Oh, oh boy, I am having a Monday. That's supposed to be a 7. And then what? Plus 7y plus 7y plus 49, y squared plus 14y plus 49. My point is this is the same as that, okay? A common mistake is that people think this equals that, which is not true, because that would be y squared plus 49, when in fact you would get that, or that, a middle term. So be careful with that. Let's take a look at some more of these. So b minus 1, the quantity squared, equals b minus 1 times b minus 1. Multiplying together the two factors of b minus 1, we get b squared minus b plus 1. Combining like terms, b squared minus 2b plus 1. If we have 6y plus 3, the quantity squared, that's 6y plus 3 times 6y plus 3, which is 36y squared plus 18y plus 18y plus 9, which is 36y squared plus 36y plus 9. Let's see, how about this one? 1 minus 4a, the quantity squared, is 1 minus 4a times 1 minus 4a, which is 1 minus 4a minus 4a plus 16a squared, which is 1 minus 8a plus 16a squared, or 16a squared minus 8a plus 1 if we were to write it in standard form, descending powers, that is. Okay, but this one, d plus 0.2, the quantity squared. So that's d plus 0.2 times d plus 0.2, which is d squared plus 0.2d plus 0.2d plus, let's see, 0.2 times 0.2 would be 0.04, right? Because remember, when you multiply decimals, okay, you ignore the decimals, do the calculations, and then you go back and count the number of digits to the right of the decimal point. So here's 1, 2. So then you move the decimal point that many places to the left. Combining like terms, d squared plus 0.4d plus 0.04. Okay, how about this one? C squared plus d squared, the quantity squared. So that's c squared plus d squared times c squared plus d squared, which is c to the 4th power plus c squared d squared plus c squared d squared plus d to the 4th power. Combining like terms, c to the 4th plus 2c squared d squared plus d to the 4th power. Notice that I wrote this c squared d squared, and here, even though it was d squared c squared, I put the variables in alphabetical order so that I could identify these as like terms. Because you might look at c squared d squared plus d squared c squared and not see that they are alike. So that's why I wrote them both in the variables in alphabetical order. Okay, how about this one? Y minus 5/3, squared. So that equals y minus 5/3 times y minus 5/3, okay, which is y squared minus 5/3 y minus 5/3 y minus 5/3 times minus 5/3, it would be plus, okay, 25/9. Again, you multiply fractions straight across. Combining like terms, y squared minus 10/3 y plus 25/9. And again, I want to remind you that in WebAssign, in fact, typically, even not in WebAssign, you don't use mixed numbers for coefficients. So you would write y squared minus 10/3 y plus 25/9. Okay. Now, here is a different kind of situation where instead of having something like that, which goes to here, and then you FOIL it together, we're going to look at two factors that are not identical. In fact, they are referred to as a conjugate pair. You have the sum of two numbers times the difference of the same two numbers in the same order. When we FOIL that together, we get the following: y squared minus 6y plus 6y minus 36. Combining like terms, the middle terms cancel out, and we get what is called the difference of two squares. Why? Well, first of all, that's a difference, and that's a square, and that's a square. So we've got a square minus a square. That's going to happen whenever we have this conjugate pair situation. The two middle terms are going to cancel each other out. Let's take a look at some more examples of that. Let's see here. 5t plus 4, 5t minus 4. So FOILing this together, 25t squared minus 20t plus 20t minus 16. Combining like terms, the two middle terms cancel each other out, and we're left with 25t squared minus 16, the difference of two squares. This, for instance, this is 5t squared minus 4 squared. These two bases are these two numbers here, but we would write the final answer like that. Okay, let's see here. About this one. 0.3 minus 2c squared times 0.3 plus 2c squared. Now, in the previous example, we had the plus and then the minus. The plus and then the minus, but multiplication is commutative. So this is still conjugate pair. You've got a minus and a plus, but same thing. Okay, so we're going to get, let's see, 0.3 times 0.3, that's going to be 0.09. 0.3 times 2c squared would be plus what? 0.6c squared. 2 times 0.3. You'd have 6, and then you'd move over one place, so 0.6. And then minus 0.6c squared, and then minus 4c to the fourth. The two middle terms cancel out. 0.09 minus 4c to the fourth. Questions there? All right. Now, what about this case? What if I've got x plus 4, the quantity cubed? So now instead of having two identical factors, I'm going to multiply together 3 identical factors. But I can only multiply them 2 at a time. So I'm going to do these two first, okay? And that's going to give me x squared plus 4x plus 4x plus 16, combining like terms, x squared plus 8x plus 16. But now I've got to take all of that times the remaining x plus 4 factor. So then continuing, I get x cubed plus 4x squared plus 8x squared plus 32x plus 16x plus 64. X plus, like that, all right? Combining like terms, x cubed plus 12x squared plus 48x plus 64. So again, this is not equal to x cubed plus 4 cubed, okay? So don't make that mistake. Okay, let's see, how about this one? 3x minus 2, the quantity cubed. So that's 3x minus 2 times 3x minus 2 times 3x minus 2. But we're going to multiply two of them together, take the results and multiply that by the third one. Okay, so this is going to be 9x squared minus 6x minus 6x plus 4, 9x squared, combining like terms, minus 12x plus 4. Then we're going to take the results times 3x minus 2. So we get 27x cubed minus 18x squared minus 36x squared plus 24x plus 12x minus 8. Combining like terms, 27x cubed minus 54x squared plus 36x minus 8. All right. Now, in a previous section, we looked at adding and subtracting polynomials. Yesterday and today, we've been looking at multiplying polynomials. So now we're going to kind of have a mixture where within the same problem, we'll have both multiplication and addition, or multiplication and subtraction, et cetera, et cetera. Okay, so how about this one, for instance? Let's see. 2 times the quantity, x squared plus 7x minus 1, minus 3 times the quantity, x squared minus 2x plus 2. So first of all, let's follow order of operations as we always would. We'd look inside the grouping symbols, x squared plus 7x minus 1. There's no like terms in there, can't do anything. Second grouping symbol, same thing. So we're forced to distribute. So we get 2x squared plus 14x minus 2, and then minus 3x squared. Minus 3 times minus 2x is plus 6x, and minus 3 times plus 2 is minus 6. Now we'll go back and do the addition and subtraction by combining like terms. Those are like terms, those are like terms, and those are like terms. 2x squared minus 3x squared would be negative 1x squared, okay? 14x plus 6x would be plus 20x, and minus 2 minus 6 would be minus 8. So negative x squared plus 20x minus 8. Okay, let's take a look at this next one. 2t times t plus 2 plus t minus 1 times t plus 9. Again, I can't do anything inside of the parentheses. There are no like terms. So I'm going to distribute 2t squared plus 4t plus t squared plus 9t minus 1t minus 9. I'm going to keep that group together. 2t squared plus 4t plus what? T squared plus 8t minus 9. That is combining these like terms. But now distributing the plus sign, 2t squared plus 4t plus t squared plus 8t minus 9. Combining like terms, 3t squared plus 12t minus 9. Now, you might be wondering, why did I bother to put these parentheses here? Okay, let's take a look at this next problem. That will hopefully answer that. Let's see, I've got 3x plus 4 times 2x minus 2 minus the quantity 2x plus 1 times x plus 3. So we'll do the multiplication first. That is, we'll distribute. So we get 6x squared minus 6x plus 8x minus 8. And then we've got minus 2x squared plus 6x plus x plus 3. But wait a minute. Aren't we subtracting that whole product? So we need to subtract the entire results. Okay, that's why we need those grouping symbols. Now, combining like terms here, 6x squared plus 2x minus 8, and then minus 2x squared plus 7x plus 3. So now I've got 6x squared plus 2x minus 8, but I'm going to distribute minus 2x squared minus 7x minus 3. So because I'm subtracting that whole thing, I need to keep that whole thing grouped until ultimately I distribute that subtraction. So now combining like terms, 4x squared minus 5x minus 11. Okay. Any questions about that? You really got to be careful of those subtraction signs. Okay, let's see here. How about this one? Negative 2h times 7h minus 2, the quantity squared. So first of all, we get negative 2h times 7h minus 2 times 7h minus 2. Now, multiplication is commutative. So at this point, I have a couple of choices. I could do this first and then go from there. Or I could do this first and then go from there. I'm going to go ahead and do this first. So now I've got negative 2h times 49h squared minus 14h minus 14h plus 4, negative 2h times 49h squared minus 28h plus 4. Now I'll distribute minus what? 90 or negative 98h cubed plus 56h squared minus 8h. If I were to have multiplied those together first and then distributed those to here, I should get the same answer. Any questions about that? Okay. Let's see here. Let's take a look at this. This is a lookalike section. Well, let's see, we've got x, y, the quantity squared. This goes back to section 5.2. A product raised to a power, you attach the power outside to each factor inside. But let's say you've got x plus y squared. That's not a product inside, that's a sum. So this becomes x plus y times x plus y, which is x squared, plus xy, plus yx, which is xy, plus y squared, x squared, plus 2xy plus y squared. So note the difference, okay? A product raised to a power, you do this. A sum raised to the power, you don't write x squared plus y squared. There's that middle term in there, okay? Let's see here. Here's another example of that. Let's say we've got 2b squared d, the quantity squared, okay? So that would be 2 squared, b squared squared, d squared, or 4b to the 4th d squared, a power raised to a power. You multiply the exponents. Again, that's back in 5.2. At some point you want more about that, ask me and we'll go into more detail. But let's say I've got this instead, 2b squared plus d, the quantity squared. So that becomes 2b squared plus d times 2b squared plus d. We get 4b to the 4th plus 2b squared d plus 2b squared d plus d squared. Probably should put those closer together. So we've got 4b to the 4th plus 4b squared d plus d squared. Notice the answers are quite different, okay? So don't get those two operations mixed up. Okay, any questions? All right, so tonight we're going to do 5.7. Tomorrow, Tuesday night, will be section 5.8, dividing polynomials, as well as the chapter review. Wednesday, we'll review, and then I believe Thursday, let's see, let me double check that. I think Thursday is your next test. Let's see. Oh, wait a minute. Hang on, this is Monday. What am I forgetting? That's right. We're going to spend 2 days on section 5.8. My bad. So 5.7 tonight. Tuesday, we'll do the first part of 5.8. Wednesday, the second part. Thursday, we'll review. Friday will be the chapter 5 test. Okay. Anyway, that's all I've got for you. I'm going to go ahead and turn off the recording.